like this. Instead, I went like this.
Because the third would have only been for the one?
Bingo. If I put cubed up here, or quad, or quint, or sext, or sept, 3, 4, 5, 6, 7 power, this means I am only taking the 1 to the third power. Do you understand that? That's why I don't put the 5 over here. Because if I go 5 to the 1 over here, this is still going to be 5 times 5 times 5. And this is going to be 1. Even if I put the parentheses inside of here, it's going to be 1 times 1 times 1, which is just going to be 1. Here, if I want to be able to say, because if I multiply this across, it's going to be 2 times 2 times 2. This one over here simply means the 1 is being cubed. The 2, if you will, is staying to the first power. So I have to use parentheses. Let's finish it off.
Yeah, I've worked with powers before and stuff.
Pardon?
I've worked with exponents before, so I understand.
Good. Let's make sure everyone does. All right. 5 cubed is what? Somebody help me out. That means 5 times 5 times 5. 5 times 5 is 125. It's like somebody gives you 5 quarters, right? That's 125 times...
Wait, so when it has the parentheses, then it means you also multiply the 2?
Yeah, parentheses means times.
So it's 8 and 1. So 1 over 8.
Very good. 125 times 1/8. But we've already kind of agreed upon that we would turn the 125 into that, which gives us 125 over 8. Now, is that going to go ahead and be divisible by 8? And the answer is no. However, I can still turn it into a mixed number. How many times does 8 go into 1?
No.
How many times does 8 go into 12?
No. Or wait, what's I was thinking
with the remainder of 4. How many times does 8 go into 45? Begin to the and ends with an IV. Good. And then 5 times 8 is 45. And then what we're going to do is we're going to have and 5/8. Again, if you're doing this for me, 125 over 8 is perfect, but for the sake of understanding the conversion into the mixed number for pre-algebra, please stick it up there. Okay? Bases. When we switch to using exponents, powers. Okay? Now what I'd like you to do, because you both have paper, is I want to go ahead and see if you can turn this around for me. What I'm going to do is I'm going to go ahead and give you something that's written with exponents, and I want you to write it without the exponents. If you will, I'm going to give you this, and I want you to give me that.
Yeah.
Good. Let's go to it, please. Clean sheet of paper or a sheet of paper, please. Again, this is for lesson 2-9. Are you ready?
New sheet of paper.
He just said or.
That's okay. Anywhere you want to put it, dear. Okay, let's go 7 to the 3rd times 1/3 in parentheses to the 4th power. 7 to the 3rd power times, in parentheses, 1/3 to the 4th power. And if you need to use this as a model, by all means, use it as a model.
Do you want to write the problem you just said on the board so Aiden can see it?
Oh, yeah. 7 to the 3rd times 1/3 to the 4th. Again, I am not asking you to solve the problem. I'm simply asking you to go ahead and move from bases and powers that are greater than 1 into just laying everything out. And you haven't got a... You can just show me? Ooh, that's very nice. Ooh, that's very nice. Now, Aiden, you have to show me too that this is very nice. So I know that what you're going to probably do, you're going to go 7 times 7 times, oops,
Yeah, exactly.
times
Hi,
7.
Hey Aiden, what's up?
And again, the reason I have 3 of them over here is because that's what the power tells me to do. The base must be placed down the number that the power says. So this is going to be 7 times 7 times 7, which Lauren will go ahead and tabulate for us on the mini box. Unless, of course, you want to do it in your head. Times 1/3 times 1/3 times 1/3 times 1/3.
How do you turn this on?
By pressing the on button.
Where is it? Oh.
Yeah, I have a real tough time with calculators too. In other words, the key over here is we're going to multiply this across. The reason I have 4 3's over here is because I have the parentheses over here. Does that make sense?
Does it?
Yes.
Yes.
Real basic. Now let's go ahead and show you why this can be a little bit difficult. Because you're saying, gee, Mr. Kevin, I already know this stuff. So what does the math teacher do? The math teacher says, let me throw the proverbial wrench into the machinery. And remember, the dot will go ahead and mean times. Please go ahead and take this and put it in base and power form. I have A times B times A times C times C times B times B times A times C. How would we do this one? You have 5 seconds. There's your hint. You'll notice that what we do is we have 3 different letters up here, 3 different variables up here. So what do? We place them in alphabetical order, A, B, C. And then we simply add the number of letters. And that number of that specific letter is going to be placed as the power of each of these bases. This is really important because all we've looked at so far is as the base has always been the number. Now we're saying what the base can do is now the base can be a letter. Welcome to the world of algebra. How many A's do we have, Lauren? How many B's do we have, Rem?
3.
How many C's do we have, Aiden?
3.
Very well done. So what our product is A to the 4th power, B to the 3rd power, C to the 3rd power, or if you prefer a bit more informally, A to the 4th, B to the 3rd, C to the 3rd. Now it would not be wrong if you wrote this answer as B to the 3rd, A to the 4th, C to the 3rd. It also would not be wrong if you wrote it in backward alphabetical order, C to the 3rd, B to the 3rd, A to the 4th. But this is a little bit easier because it's more of a convention that mathematicians agree upon.
A, B, C, D, E.
Yeah, not A, C, F, D, L, B, Q. I do not want to be like you. Unless, of course, you're good at math. Thank you. So let's look at a couple of our examples over here. And I think the only ones you're going to really encounter difficulty with over here would be with the fractions. And that's if you forget, when we have the parentheses, that means both the numerator and the denominator are going to go ahead and be squared. Oh, by the way, squared means 2. We don't say seconded. Well, we could say to the second. But it means squared. And cubed means to the 3, to the 3rd. So let's take a look at this. We're at Rem, let's go ahead and give us page 128.
Next page. We're there.
Good. If you will, please read, turn the numbers or the letters into a base and a power. Number 1, 2 times 2 times 2 times 3 times 3 times 3.
2 cubed times 3 cubed.
2 cubed times 3 cubed. We do not have to solve it. I guess we could, but this is all about setup. Next one for you, Lauren. R times S times R times R times S times S times R times S. What are going to go ahead and be your 2 letters that repeat themselves?
R and S.
R and S in alphabetical order. How many R's do we have? Take a look at the book, please. We're at number 2 on page 128.
5 R's and 3 S's.
Very good. So the answer would be written out how?
I guess R to the 5th power and then S to the 3rd.
Very good. R to the 5th power and S to the 3rd power. Now, Rem, I want you to do the next one. We have 1/2 times P times K times 1/2 times P times P times K. How is that going to go ahead and look?
So we'll have 1/2 squared times P cubed times K squared.
Okay. Rem has said we'll have 1/2 squared times K squared times P cubed. Anybody disagree with that?
That includes you too, Aiden.
Remember what we talked about? There's 2 different ways of writing fractions that would have exponents. Your fraction should look how?
Oh, with parentheses.
With parentheses around the 1/2, because that means we'd be squaring the 2 in the denominator as well as the 1 inside the numerator. Sehr gut. Or as they say in Germany, sehr gut. 2. Okay. Now we're going to go ahead and move on to our next lesson, which is scientific notation. I am going to pull out, don't look, magical dust, and I've just thrown it on all of you. What you now all are, everyone in this room is a scientist. Now, why did I do that? Because scientists work with math. Scientists work with really big numbers. Say, for instance, what you had to do is you had to figure out the velocity, meaning the speed at which an object is falling. And you're looking at an object that has a mass of 17.96421 grams. And it's falling from a height of 3,941.62 miles. And this thing over here is hiding or broken. Or somebody took it to school with them, and you haven't got one. So do you have to go ahead and say, ah! Or do you say, new problem? I can solve that real easy. Okay. The magic of lesson 210 lies in moving the decimal point to where there's just one number to the left of the decimal point. Okay? I'm going to go 1.796421 times 10 to the first. All times, remember I said I just want one number to the left of the decimal point? I now go 3.0 941.